This is Wei Yu Sun's milestone number 3 video. Per my milestone contract, in this milestone, I'm supposed to do some setup to make sure the presentation, anything we need for the presentation will be done. During the time, I discovered that instead of using both Arduino and ESP8266 for the connection, I'm actually be able to just put everything on ESP8266 to cut out the power and the size. So basically, I have to do some of the work I've done during milestone 1 and 2, including testing all the sensors I'm gonna need for the documentation. There's a DHT11 for temperature and humidity, and there's a lux for the cell. And also including I also require the MQ07 carbon monoxide detector. It'll be able to tell you whether or not carbon monoxide is over the dangerous level for warning purposes. And also put in the motion sensor, even though we might not be demonstrating this during the presentation. One other thing I run into problem is the relay. This is a 5-volt relay, which works just fine with Arduino because its digital level is 5 volt. When we come with ESP8266, the logic level on the chip is only 3.3 volt. And I'm going to do the small demonstration here. Here I have a power source, which is the rail voltage set to 5 volt. Put this in here. So as you can see, and the other side is 3.3 volt. As you can see, if I touch using 3.3 volt as my controller, let's say demonstrate the signal from the GPIO pin. For 3.3 volt, you can see it does not turn on. It does not generate enough power to move the coil to trigger the relay. So the solution I discovered is to use a NPN transistor as a shifter switch. So once GPIO input a 3.3 volt from here, the 5 volt will be able to cross the relay in order to trigger it. And here comes the demonstration. I put in 3.3. This. Okay, let me put the pin back. Okay, just pause. Okay, back to the relay demonstration. So after using the transistor and the resistor to make a switch, I'll be able to trigger the relay at 3.3 volt. Just fine. Yay! The other thing I'm prepared for the demonstration is to build a small sensor station. It contains the following sensor on the one chip, which is relay, DHT11, PIR, and the sensor photocell. And right now, let me demonstrate how it sends this value to the web server. Here's a demonstration for the sensor station. This device right now contains 4 4 sensors and sending 4 data, including a temperature and humidity, lux, and carbon monoxide sensor. And here's the Arduino code. It looks like. Yeah, we start with the basic setting on the Wi-Fi setting, and the mode. And here's a HTTP comment on posting the data to the server. Right now, currently it's set up every 20 seconds for demonstration purpose. And here's a result. It's still posting as we speak. You can see the value is posting. Lux is 750 because it's quite bright. Temperature 26 Celsius. And humidity is 34%. And to check whether or not this data actually being sent to the server, let's go to the dance interface. Let's click on data value and check the historical logs. And see the brightness is changing with actually changing reflected to the time. It is 11:46. And so is the other, and check the current data. It shows the right now it's been posting. Okay, this 27 should supposed to be Celsius. We'll fix it later, but all the others represent to the current value. Okay, for this part, I'm going to demonstrate the parsing, which is the hardest part for this program. For my part, here you can see there's a parsing order. You need to look into the mode and to check annual auto or manual. If it's auto, you'll reach a threshold value. That threshold value will be compared with current value that read from the sensor, and then make the decision. For as a simple example, if the current brightness is less than the threshold lux, we'll turn on the LED to increase the lux. Otherwise, you'll be off. And for manual, it just look easier. You just check the state. If it's 0, we turn off. If it's 1, we turn on. And here's my demonstration. So how we're wiring. It's recommend to using an external power source because this ESP8266 could take up to 200 milliamp, which is not very good for your computer, laptop, or any port. That's why I take down this power voltage source from there. And let's go check the current value online. This is the 3 pages are pulled directly from the web server. So you can see it's set to go to auto mode, and when you go to auto mode, it says compared to the logs, and the value should be 1000, which is pretty bright. That's what we need. And just it says for the manual mode, it says fan and turn on, but right now I'm just using an LED. That's why it's not gonna bother me in this part. Okay, right now let's go check the Arduino code. Okay, this Arduino code is very long. So similarly, it compares the first part is the same for the setup. You just connect to the Wi-Fi, and I use switch case for the decision making. It's very long. So you read out here, there's a JSON parse to read from the PHP file from website. Parse. And if it's 1, we go to auto mode and repeat the same thing. Okay. And you can see right now, I keep running. Let me pause this. Oh, you can see mode. This is reading from the website. So the mode is auto and 1. Here's what I read, which is, and the value parsed from it is correct. And for the logs, so hence it's going to auto mode. And the logs here, we desire the logs is 1000. Right now, yeah, for the setup on this module, I said that when the light is on, it'll be 1024, which is max out the analog value. Okay, to demonstrate this parsing is working, you can see right now the logs value being measured is 1024. So max out because the light's on. And when I put my hands over the sensor, the LED will be on because current logs value will be, it's 934, it's lower. And we'll be expecting some delay because every time we need to run through the parsing through mode and then go to the correct mode of this. It's off. That's a demonstration for the parsing.